Exponential functions. If a is bigger than 0 and a not equal to 1, then f of x equal c times a to the x is an exponential function with base a. And remember the conditions on a. A is a number that's bigger than 0 and not equal to 1. So we have these cases. We have the case a is bigger than 0 and not equal to 1. So the exponent is x, which could be any number you want, and a is obviously a number that's not 1 and bigger than 0, always positive. And the point 0c, if you put 0 in for x, you get c, is the initial value. That's extremely important for applications. So we have two regions to consider. We're looking at a region when x or a is between 0 and 1, and we're looking at a region when a is bigger than 1. That's pretty much what it comes down to. If a is between 0 and 1, or a is bigger than 1. Well, let's start with the first. Sketch the graph. We want to make a table. I want to put all of those on the same grid. So I'm going to extend the line this way. I'm not doing this 3 times. Take x. I'm going to make 2 to the x in blue, 3 to the x in green, and 4 to the x in red. And then I'll generalize in general what that means. I'm going to take x to be 0, 1, 2, 3, negative 1, negative 2. So if I replace x by 0, 2 to the 0 is 1, 3 to the 0 is 1, 4 to the 0 is 1. If I let x equal 2, 2 to the 1 is 2, 3 to the 1 is 3, 4 to the 1. If I square each of those, 2 squared is 4, 3 squared is 9, 4 squared is 16. A 3, 2 to the third power is 8, 3 to the third power is 27, 4 to the third is 64. Now comes the negative. If I put a negative 1, 2 to the negative 1 is 1 over 2. 3 to the negative 1 is 1 over 3, and 4 to the negative 1 is 1 over 4. What if I put a 2? 2 to the negative 2 is 1 over, let me just space this out a bit more. We need a bit more space. And we have plenty of it. There we go. So the negative 2 there will make this 1 over 2 squared, which is 1 over 4, 1 over 9, 1 over 16. If I have to try negative 3, 2 to the negative 3 is 1 over 2 cubed, 1 over 8, 1 over 27, and 1 over 64. So let's talk about the blue graph. 0, 1, 1, 2, 2, 4, 3, 8, 'I'm going to have to, now that I added space, it's going to work for our benefit. I'm going to lower this a bit more and center it properly. There it is. So 3, 8. So to the right, it looks kind of like a parabola, but it's a bit sharper than that. I'm not going to get into that. Now I get to the negatives. Negative 1 1/2, negative 1 1/2, negative 2 1/4, negative 3 1/8. Do you see, no matter how small I choose the x, y will get very close to this line, but can never be 0? Isn't that our definition of an asymptote? So it seems for the blue, y equals 0 is an asymptote. If I go for the green, so now I'm looking at this column, I want to plot these points. What happened? So this is the case. This is the case. Remember, x is between 0, bigger than 0, and not equal to 1. 2 is there, 3 is there, and 4. This is the case when a is bigger than 1. If I pick a 0, 1, 1, 1, 2, 3, 2, 9, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't get to go 3 because that's big. So to the right, it seems the bigger the number is, the steeper this graph is. To the left, negative 1, 1/3, negative 1, 0.3, negative 2, 1/9. So it seems to the left it's below. When I get to my 4 to the x, 0, 1, and the asymptote still seems to be y equals 0. 1, 4, 1, 1, 2, 3, 4, just as expected. 2, 16, way up there. So we know that this is going to go even sharper. To the left, negative 1, 1/4, it's even below. So again, very close to 0, but never reach. So in general, if I say sketch a graph, this is a side note. If I say sketch a graph of y equal a to the x, and if a is bigger than 1, this is what you need to show me. You need to keep track of 3 things. That point for b, that line, and the shape. If a is bigger than 1, I need you to label the point 0, 1 clearly for me. The shape must be, this is what we call exponential growth, left to right it's growing, and the asymptote you must label. So, if I was to say sketch a graph of y equal 2 to the x, you can give me this graph, I'll accept it. If I was to say sketch a graph of y equal 3 to the x, you give me this graph, I'll accept it. If I say sketch a graph of y equal 4 to the x, you give me this graph, I'll accept it. I will not ask you to plot points. You don't have to be this precise. And what do you think happens if I give you a graph of, and here, y equal 3 to the negative x. 3 to the x is a graph that looks like this. We just established that. Multiplying the x by a negative, doesn't that reflect the graph with respect to the y-axis? If I reflect the graph with respect to the y-axis, doesn't this just flip and becomes exponential decay? Do you notice everything else is the same? The same 0, 1, the same asymptote, the shape switches. Instead of exponential growth, it becomes exponential decay. So, you want to plot points, by all means knock yourself out. And by the way, y equal 3 to the negative x is y equal 3 to the negative 1 raised to the x, and isn't that 1 over 3 to the x? So what does that indicate? That indicates if, in general, if a is between 0 and 1, then y equal a to the x would look like 3 things you need to maintain for me, just like we did in the previous graph. You're going to show me it's decaying. You're going to label the point 0, 1 for me clearly, and you're going to keep track of the asymptote. So when I get to this problem right here, I say sketch a graph. I don't need to plot points. All what you have to do is, if you use the grid as 1 unit each, that's fine. If not, you have to label it. So if I gave you a grid and it's 1 unit each, and you labeled that. You don't have to. What do you think this does? I'm going to show you both ways of graphing this. One way of graphing this is for you to say, you know what, I know what this does. This multiplies the y values by 2. This multiply the y value by 2. So the point 0, 1, there's the y. Multiply it by 2. I will say that's 0, 2. The shape doesn't change. And multiplying 0 by 2 remains y equal to. You're done. Y equals 0. Or you could pick points. Not recommended, but you could. Depending on how much time did you actually spend on that one homework assignment that we did. What is it? 3 to 6. Or you could say forget all of this. Now, remember how I taught you how to pick 3 points? Do the same. Where does that equal 0? A point above it and a point below it. What that does, that gives you 3 points. You need to get an idea of how that looked like. Put 0 in there. 2 to the 0 is 1 times 2, that's 2. Put a 1 in there. 2 times 1 is 2/3, and put a negative 1 in there. That will be 2 times 1/3 to the negative 1. That will be 2 times 3, that's 6. If you put those on a number line and say, well, let's see. If you say, we're going to take 0, 2, 1, 2/3, and negative 1, 6. Now your graph is a lot more accurate. If I say sketch a graph, I don't care much about how accurate it is. You label that line for me clearly and you tell me that's 0, 2, and you're very happy. You want to pick points, you can. You don't have to. And if I run down to the next problem, if I gave you a graph, can you tell me what the equation is? Well, I know that f of x equals b to the x. So I have a point. This is x and y. Y equal 1/4, when x equal negative 1. How do you solve that? Isn't that 1 over 4 equal? Isn't that 1 over b? You could cross multiply and say b equal 4. So my equation becomes, or I should say, my equation becomes f of x equals 4 to the x. Here they're telling you that the leading number is 1, which is not a big deal. The book does that, so I matched it. But it doesn't always have to be 1. And I graph the function by using transformation. And I broke this kind of for you into pieces. Let me tell you how it works. The graph would really ask you to sketch a graph of part C. So the way you would do it, to get to part C, you will do a quick sketch. Here I made them 3 different problems. But if I was to ask you just to graph part C, what you do, you look at 1/4 and you do a quick sketch on the side. What does the negative do? Multiply the y by negative, reflect with respect to the x-axis. And what does the 2 do? Shift that graph 2 units up, so the asymptote shifts up 2 units, and the graph looks like that. So here, there's the point 0, 1. It's exponential decay because that's between 0 and 1. Label that as 0, 1 clearly. Label the asymptote. Full credit. That's all I want. You want to pick points? By all means, knock yourself out. What happens when you multiply the y by a negative? You reflect this graph with respect to the x-axis. So take this graph and reflect it with respect to the x-axis. It looks like this. Where this point is not 0, 1, that point is 0, negative 1. And multiplying 0 by any quantity, that's still 0. You're done. That's all I want. You want to pick points, you could. 3 points will do the trick if you wish. And what does the 2 do? Now that I did this, the 2 is going to shift this graph 2 units up. The line y equals 0, shift it up 2 units. That's really y equal 2. Label that clearly. The point 0, negative 1, shift that 2 units up. That becomes 0, 1. Give me the same shape. And me and you are very happy. And if you labeled it this way, that's fine. You could make certain by giving that label. And there it is. Now I give the grid on the exam, so you really don't have to worry much about labeling unless you're going to rescale it. How about here? Well, again, I would start with, and this is a very good idea to do, 5 to the x. Well, 5 to the x, I know that graph, so I do this on the side really quick. I always do. This is only me though, you don't have to do this. 5 to the x, I say, okay, 5 to the x looks like this. That's 0.01. 2 times 5 to the x, multiply the y value by 2. That makes this really 0, 2, and everything else is the same about. And what does the 1 do? Now I provide the actual graph. So those two, that's not part of this at all. That's just for my own reference. Now that I know how that looked like and I have a good idea how it looks like, I could say, well, okay, let's go for it is 0, 2, y equals 0. Shift it up 1 unit, that's going to be y equal 1. And there's 0.02. If I shift that 1 unit, 1 unit, 0, 2, you know what? I'm going to rescale this as well. I should have used the smaller grid. So 0 is going to go up 1 unit. I label that clearly, y equal 1. And the 0.01 will be 0, 3 now. 0, 2, I'm sorry, will be 0, 3. And the shape matches. Now, even though it says use translation, I normally say sketch a graph. I can care less how you show me that. So you label those 3 units, that's good. You could pick points. Nobody's going to stop you. Where does that equal 0? A point above it and a point below it. Put 0 in there. 2 to the 0 is 1 times 2, that's 2 plus 1, that's 3. Guess what? I just got that point. 1. 5 to the 1 is 5. Times 2, that's 10, that's 11. At 1, you are at 11. So this graph is a lot steeper than I'm showing. But again, we just want the shape. I don't mind. The green or the black will do. How about this graph? Well, 7 to the x is a very sharp graph. If you're going to pick points, you're going to have to put a lot of units on that scale. All what I'm going to say, 7 to the x looks like this. The negative 3 will shift that graph 1, 2, 3 units down. The point 0, 1 shifted 3 units down, 1, 2, 3. There it is. There's the shape, done with the graph. If you rescaled that just to be certain, label those, this way you get all the credit. And if I go to part F, 3 to the x is right there. What does that do? That will shift the graph 1 unit to the left. And that will shift it 2 units up. So keep track. That's at negative 1, 3. The line y equals 0. Shift it to the left, doesn't matter, but shift it up 2 units. Now it's y equal 2. And the shape is exponential curve. There it is. And that's pretty much it for this section.